One.
Now let's talk about the meniscus. A meniscus is the curve you see at the surface of a liquid in a container. We always read the volume at the bottom of the meniscus to ensure accurate measurements. Here's an example of a properly read meniscus in a beaker. We should always take readings at eye level to avoid parallax errors. First, let's define what we mean by stock solution and a dilution. A stock solution is a concentrated solution from which we make a diluted solution by adding salt. The relationship between the two is explained using the dilution equation M1V1 equals M2V2, where M is the concentration and V is the volume of the stock solution, and M2 and V2 are the concentration volume of the diluted solution. In this example, we will dilute a stock solution of copper sulfate to a lower concentration using this formula.
Begin by priming your beret. You prime your beret. First, squeeze this bowl on top of your beret. Suck up to your solution. Make sure it does not go up to the bowl. Just a little bit. Slowly. Now you can just put your finger on top. Just roll it around. Just a little bit. Make sure it coats evenly the entire beret. Pour it out.
Now somebody gets to do
Boom, you primed it once, you need to do this twice.
2.5.
Squeeze all the bread, put it on your bread. Use solution. Put down, let go, and you're done.
Now we will be transferring the stock solution into our volumetric flask for our first dilution. We need 12.5 milliliters, so we will prime the bowl and take out 9 milliliters.
Okay, yeah, you know what? Yeah, that's okay, that's fine. Okay, so this is for the stock.
We take out any air bubbles, and then we transfer it to a graduated cylinder. Did you read it?
I'll go again.
That was 7 milliliters, which means we need another 5.5.
Okay. So you guys want to go do that?
Exactly.
Yeah, the unknown. Get two bets. And
So this is 5.
bets and then
We will get another 0.5 after this.
yes. Okay, we'll go with this. Do you want to start with so such a good
0.5 into here. And we squeeze in there.
We'll carefully transfer this one, the stock solution, into the volumetric flask. Carefully insert manicures. Insert the volumetric. Is that all? I think that's all. Transfer it all, and answering the manicus is correctly read at the graduation mark.
So the main point of a dilution is to adding a solvent such as water, in this case it is water, to your solute, which is our copper amine. So we're going to add our water to our copper amine to reduce the concentration. Currently we have 12.5 milliliters in here. We're going to add some water to a 25 milliliter mark in order to dilute it to 0.01. Yep. Now look. Zoom in at the meniscus. The meniscus should be about the 25 milliliter mark, like it is right here at the bottom of the meniscus is what you're trying to measure. It's currently at the 25 milliliter mark, so it's good.
Okay, now we're inverting the flask and gently mixing it. Okay.
Once your dilution is complete, it is important to clean your lab space properly. Make sure you dispose of any waste properly and make sure you keep your lab area clean. That's how you cleaning up those things.
So this is how we found the molarity of each data point. For our stock, we use the grams of copper pentahydroxide that we delivered, which is 0.125 grams, divided by the molar mass, multiplied by the amount of the volume of the solution, and then we convert that into liters, and we get the molarity of our stock solution to be 0.2000. For the dilution, we're going to use our stock solution, which is at 0.020 grams over liters, not grams, moles over liters. And we're going to put that into our CV equals CV equation, which is our dilution equation. So we have our stock initial value times our volume delivered of stock, which is 12.01 milliliters, equals an unknown amount of molarity times 25 milliliters. So we're going to get a molarity of our first dilution of 9.608 times 10 to the negative 3.
Thank you for watching this tutorial on dilution. Now that you've seen how it's done, you can apply it to your own chemistry lab. Don't forget to check your calculations and to reserve your accurate data for the best results.